So today we will be looking into the design of ALU. Okay. Can someone tell me what's an ALU?
So
Arithmetic and
arithmetic and
logical
logical
unit.
unit.
Correct. So which means it needs to have two units. One is the arithmetic unit and the other one is logical unit. So what are these functions that are performed by arithmetic unit and logical unit? Can you just specify me?
Sir, addition, subtraction,
Good, good. So this is performed by logic or arithmetic?
arithmetic, sir.
Arithmetic, good. And the one which is performed by logical units?
So bitwise and bitwise or
Good, good. So your ALU should have a combination. Okay. In fact, the name itself suggests arithmetic and logical unit. So it should be able to perform arithmetic operations as well as logical operations. Can someone tell me what structure is this?
So
This
two
one?
is to one mux.
multiplexer.
Yes, good.
Multiplexer.
That's a multiplexer, and specifically it's a 2:1 mux. Good. So here what we are looking at is, if in case we are performing arithmetic operations, then this block should be selected. If in case we are doing logical operations, then this block should be selected. So in order to do this multiple selections, okay, we use something called multiplexers. So I think all of you are very much aware of a multiplexer, which has multiple inputs, but it will have just one single output, right? So here now, if we can look at this structure, which has inputs x and y internally, but externally I will name them as A and B. And here also x and y, but externally it is A and B, right? And the outputs, of course, they are the inputs to our mux. And the final output will be the instruction as per our select line. Okay, so we will have something called select line. So what is this select line? Select line will actually be able to check. Okay, the select line should be connected here. It should be able to check either to take the arithmetic operations or the logical operations. Now, how do we go about doing this? Okay, now these are some of the operations which can be performed. So as someone suggested, okay, your friend suggested, uh, any addition operation or your subtraction, these all can be termed as your arithmetic operation. Logical operations can be your and or XOR, not, inversion, all these things, right? Okay. So what we can do is, since we have seen the structure here, okay, we can use some codes. Now, if I say 0, 0, 0, 0, then some first operation should happen. Transfer A, which means whatever is in A, okay, should be is in the accumulator should be transferred to some register. And then when I say A plus 1, whatever is the contents of A should be added with 1. Similarly, when I give next instruction A plus B, whatever is the contents in B should be added with contents of A. Okay, so these are some of the examples that you should be looking into, right? The other example that I want to give you here is, now this can have a full ladder, okay, and as you all know, it has x, y as inputs, c in, c out, and sum, right? So for addition, I will be using a full ladder, okay. So I can make a tabulation like this, okay, and I can make sure that what operation needs to be done, okay. So similarly, I will have a 3-bit combination here, 000 to 111, okay. And if I give this in my select line, then transfer A should happen, okay. So based on what I am doing, different operations should be able to be done, okay. Now again, here for our full ladder, we can again make use of a multiplexer. Okay, let me show you another document where it will be easy for you to understand. Whatever concepts I've discussed so far, were you all able to understand? as to what is arithmetic unit, what is logical unit, and what do they involve. So these three questions you're able to answer, right? Yes or no?
Yes, sir.
Yeah, fine. So arithmetic unit, you all know, you know what is a mux, why is it used, you know what is a logical unit, you know the inputs and what are the operations to be done by these units separately. Okay, so yeah. So here, if you can see, how many of you are aware of the programming language HDL? Are you all aware of the programming language HDL, Verilog, VHDL?
No, sir.
Okay, so in your upcoming semester, okay, in your fourth semester, you will be actually looking into these languages, okay, specifically with Verilog extensively and a little bit of VHDL. Okay, so here when I say A is 7 is to 0, which means it has 8 bits, okay, and this also has 8 bits A and B. So this is my logical unit arithmetic. What I've done is I have rearranged them. I have put the logical unit on top and arithmetic unit at the bottom. And for this mux, I have given 0, 1. So when I say 0, then logical unit, then when I say 1, then arithmetic unit will be selected. Okay. Then I'll be using something called an opcode. Okay. Opcode is like a code command. For example, now whenever you want to look up for some search using your voice-based machines. Okay, for example, if you want to search with Google, then you need to use the keyword "Hey Google," right? Similarly, this opcode is used to initiate a particular function. Now, the same connections are here. Okay, we have two inputs, and then here also two inputs, and then we have a common input. Okay, which is the opcode, and this opcode is 3 is to 0. 3 is to 0 means it will have 4 bits, 4 combinations. Okay, right. So this is my ALU. It has A, B, C in Y and my opcode. So based on my opcode, I will be able to perform different operations. Now, what is this opcode? Now, if you see my next tabulation, okay, you'll be able to understand as to what is a opcode, right? So I have bifurcated two things here. Okay, the first one is the logical, and the second one is arithmetic. Okay, so here I can complement A, complement B, and or NAND, NOR, XOR, XNOR. Okay, and if I have to put it in the form of equations, okay, this is what I will get. And opcode is nothing but my binary combination, which is ranging from 4 zeros to 4 ones. Okay, I'm just using a binary sequence here. Okay, 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15. So I will be using my binary sequence here, and for each sequence, a particular operation happens. Okay. Now, say for example, I use 0, 111. So in this case, XNOR operation happens. So XNOR of what? A, XNOR of B. Okay. So A and B are XNOR with each other. Okay. Why now? Can someone tell me why is that I'm using only A and B? Why is only A and B used here?
Because only two inputs are there, sir.
Correct, correct. So I have only two inputs here, A and B. So I need to perform operations only on A and B. And these are my opcodes. Opcodes are nothing but your binary sequence that I told you. And C is nothing but your carry. So initially, of course, we will not have any carry. It will be 0. And later on, when you add 1 plus 1, okay, then it generates the carry. And the output is going to be 0. Right. Okay. So whenever a particular function, okay, let's say I am implementing, whenever I give this command 0, 1, 1, 0, then the XOR operation happens. Then the XOR operation is actually happening between your inputs. Okay, and your inputs are A XOR B. So this operation happens, and ultimately this will be pointing to our logical operation. So here you should be able to make a selection between your arithmetic unit or logical unit based on the select lines. Okay. So can someone tell me how can this be done? How can we differentiate between logical and arithmetic? Now you have seen the diagram. So in the diagram, something was there which selects logical unit and something was there which selects the arithmetic unit. What was that?
So this is the multiplexer.
No, yes, multiplexer is there, good, but something selects logic unit,
The
something
select line,
selects
sir.
good select lines, but in select lines, some value corresponds to logical unit and some value corresponds to arithmetic unit. What value is it?
So is it the carry in, C in?
No, no, no.
So the bits, sir.
Yes, bits. Okay, you're almost there. What bit? Which bit? Now let me go back to the diagram. So what corresponds to logical unit? Now I think you can answer my question.
Opcode, sir.
Yes, opcode. And in opcode, how do I know that I'm selecting logical unit? If it is a 0, right? If it's a 0, then I'm selecting a logical unit. If it's a 1, then I'm selecting a arithmetic unit. Now let us come back to our opcode here. So here you can see all the zeros here, right? So these, whenever zeros are here, this will correspond to logic unit. Whenever there are ones here, okay, so this will correspond to arithmetic unit. Understood? Yes.
Yes, sir.
Yeah. Now here it is again a normal combination from 0 to 7, excluding the most significant bit. So from 0 to 7, of course, there will be two combinations. Here also I have 0. Here also I have 0. Now it wants to know, does it want to do y is equal to a, or does it want to do a not of a? So that will be determined based on 0 or 1. So if I give a 0, then not of a happens. If I give a 1, then y is equal to a happens. Any doubts, students, till the concept discussed so far?
No,
Any
sir.
doubts? Yes, no. If
No,
you
sir.
please ask. Yes, any doubts? Girls? Okay, so this is how your design of ALU can be done. Okay, now actually I can show you the code and the VHDL and Verilog code, and we can actually implement it. But then, okay, that is going to be out of scope of your syllabus. So as of now, whenever a question is asked, okay, uh, how is the design of an ALU done? Then you can use the tabulation that I've used previously, okay, this tabulation, And also you can use the diagram, okay, which I've shown you in my previous page. Okay, so this diagram can be shown. You can explain that, this is going to be your logical unit and it's going to be your arithmetic unit. You can mention what are the possibilities that is done in logical unit, what are the operations done in arithmetic unit, and how the selections are done, how mux plays an important role in either selecting logical or arithmetic operations, and ultimately what is going to happen. And you can summarize it also with the help of ALU symbol. Okay, you can summarize it with the help of this tabulation. Is that clear, students? Any doubts? Okay, fine.